Imagine a world where everything stands still. No motion, no speed, no energy transfer. That's a world without physics. Hey future physicists, today we are diving into momentum. How objects keep moving and what makes them stop. Trust me, after this, every moving car, flying bird or a bouncing ball will make you think momentum in action. Stick around and we'll explore the fascinating world of momentum together. But students, before we start, don't forget to like, share and subscribe to our channel. Let's learn together. Hello students, welcome in today's class. We are going to talk about momentum in today's class. But before I start with momentum, let me remind you, what did we do in the last class? So in the last class, we have started with the unit of physics which is related with forces and motion, and I have talked about all the basics of what force is and also describing all the three laws of Newton, that is Newton's laws of motion. Okay, so I hope you have seen that particular class and then you are watching this class. Only then you would be able to understand whatever I will talk about today. So I think you should be very excited. We have started talking about force. Today we are going to talk about an equal important physical quantity which is called momentum. Okay, so momentum you also is a term you also use in general. So momentum is like, how do you explain that? You have gained something. It is like that. So momentum here is also something like that. So it is the gain in motion, you can call it like that. Okay, so let me put it this way for you now, that momentum is an indicator of the amount of motion any system has gained. Okay, amount of motion any system. When I say system, it can be like a collective system as well. That's why I've shown this train here. So the momentum of the train, so it accommodates the train, all the things that are inside the train, all the passengers. So you say that the momentum of the train. If it is a single ball, like you throw a ball, then it's momentum of an object. If it is a system, then it is a collection of objects. So what is momentum? What is the physical definition or the qualitative definition of momentum? So the answer is an indicator of the amount of motion. Okay, so with that thought, let's start with today's class. It indicates the amount of motion contained by a body or a system. All right, so you now can understand that. Next, what will it depend on? So you will say two things. First, momentum, we denote it by the alphabet P. It is proportional to the mass. Why? More the mass means more the number of particles. Hence, more will be the momentum. Second, of course, it is going to be dependent on the velocity, because more the velocity, more the rate of motion, and hence more the momentum. Okay, so momentum depends on two things, mass of the object and the velocity. Okay, if you combine the two, then it becomes mass times velocity. So let's now talk about the quantitative definition. What is the quantitative definition? Momentum is nothing but the product of mass and velocity of the system. And you do understand mass is a scalar, of course you know that, and velocity is a vector. So what do you think momentum is? Momentum is also a vector quantity therefore, and it will always point in the direction of velocity. So whatever direction of velocity is, let's say if I am moving towards the right, my momentum's direction will also be towards the right. So keep that in mind. Momentum is a vector whose direction is same as velocity. Okay, so this thing is done now. It is a vector quantity having same direction as velocity. And now let's talk about the SI unit, which you of course know is going to be kg meter per second, because the SI unit of mass is kilogram and velocity is meter per second. So all this if you have in your head, I think we can move forward. But I'll wait here, you copy the important stuff and then we move forward. Alright, so next thing, let's do a very quick numerical just to get more comfortable with the formula. How are we going to use the calculation or do the calculation? So calculate the momentum of a runner of mass 50 kg running at a speed So I think this is easy. So the first part, momentum is going to be mass times velocity. So 50 times 4, that is going to be 200 kg meter per second. So can we say this is the momentum? Answer is no. Why? Because if you say momentum, that means a vector. So if you say momentum of 200 kilogram meter per second towards east, then it is the correct way of, saying that. But now you are only calculating the magnitude of momentum, the amount of momentum. Okay, so keep that in mind. So though we do that very often, but just for the sake of knowing it, whenever you talk about momentum, you should understand that it is a vector quantity, so the direction becomes equally important. Okay, a man of mass 70 kilogram walking at 1.2 meter per second, no problems here as well. You just do mass times velocity, so that's going to be 70 times 1.2, and that's going to be 84 kilogram meter per second. Just to make you a little more comfortable with the formula, okay, a soccer ball of mass 400 grams. So here, since it is 400 gram, what are you going to do? First, you will convert that to kilogram. I've already shown that calculation to you, times 25. Okay, so that is going to be 10 kg meter per second. Okay, then a car of total mass 1000 kilogram moving with a velocity of 18 kilometers per hour. So this is kilometer per hour. Let's quickly do the calculation. 18 times, first I need to convert kilometer to meter by multiplying it by 1000, and then hours into seconds by dividing it by 60 times 60. So when you do this, this is going to be 5 over 18, and this value will turn out to be therefore 5 meter per second. So you multiply by 5. So you're not putting the value of velocity as 18 because that was in kilometers per hour. Keep that in mind. These small mistakes, these small errors, cost a lot and we cannot afford them. Okay, so the answer is going to be 5000 kilogram meter per second. Very easy. Just to get more comfortable with this new quantity, I just took up this question. All right, still you can write it down, then we move forward. Okay, so the next thing, the principle of conservation of momentum. In fact, you know what, we talk about this, first again I wish to talk about the Newton's first law, second law, third law very briefly. So the first law stated that we need a force to change the state of motion of a body, or we need a force to change the momentum of a body. Now we can also call it like that any body will maintain its momentum unless an external force acts on it. Once a force acts, its momentum is going to change. Keep that in mind. So I am giving you an alternate perspective of Newton's laws today after learning momentum. Second law, we said that force is mass times acceleration. All right, so force is mass times acceleration, and if you know acceleration is delta v over delta t, that is the change in velocity. Okay, so let me put it this way, change in velocity is like v minus u. All right, it is v minus u. Final velocity is denoted by v, initial velocity is denoted by u. So can we call it like this, mv minus mu? Now what do you think mv is? So you would say that force now can be written as p final, that's the final momentum, minus p initial over the time, whatever the time is, let's say delta t. Okay, delta t. Okay, so this is like delta p over delta t. So can we today, after today in fact, again have a new way of giving Newton's second law? What is that? That the force is the rate of change of momentum. Force is the rate of change of momentum. So force tells you how rapidly the momentum is changing. I will come up with an example. Let's say you catch a ball. Imagine you catch the ball and you keep your hands very stiff. The ball will strike your hand and immediately the ball will stop in a very fraction of second. So you will feel more force. Why? The momentum change is the same. The ball was traveling, now it has stopped. So all that happened in a very short duration of time, and hence you felt more force. But if you take your hands backward like this, okay, so what are you doing then? you are causing that momentum change with a delay. So you are delaying that. So this time increases and therefore you feel lesser force. That is what shockers do, suspension systems do, or an airbag would do. So if you feel the impact and you collide with the steering or the windshield straight away, then you feel more impact. But the airbag, they don't, avoid the stop in the change in momentum. What they do is they give you more time. By compressing, they give you more time. So more time means lesser force. So I hope you are able to understand that momentum is related with force, and how, using Newton's second law, that force is the rate of change of momentum. Keep that in mind. Force is the rate of change of momentum. Please, I think you should copy this down. This is very important discussion that I've briefly had here. Two things. Newton's first law states that whenever you wish to change the momentum, you need force. Second law states that force is equals to the rate of change of momentum. Please copy this down, then we move forward. Okay. So now I think we can talk about principle of conservation of momentum. Now is the right time. So that is why, suddenly I realized that why not, let's first again look at the Newton's laws, and this is in a way also, a way of revising Newton's laws. So now you understand how principle of conservation of momentum works. So you understand the conservation word means something is not changing. So what is not changing, let's understand. But again, let's refer to the Newton's third law. Now what is Newton's third law? So you would say that if a body A applies some force on body B, then body B will apply equal and opposite force on body A. That is Newton's third law. And if I tell you that if we take this as a combined system, as an isolated system, because they are interacting with each other, but no one's interacting from outside, what is the net force? So you would say the forces are balancing each other off, and the net force is going to be 0. The net force is going to be 0. There's no force. Now, what will happen if there's no force? So imagine force is rate of change of momentum, and if I tell you that the net force is 0, then that means delta P is 0. That means P final minus P initial is 0, or we can say P final is equals to P initial. Okay, P final is equals to P initial. There is no change in overall momentum. Individually the momentum might have changed, but the overall momentum remains the same. So one body collides with the other, that is also a way of applying force. There is no change in momentum overall. Why? It's clearly showing that overall there is no force, means there is no change in momentum. That is what we call principle of conservation of momentum. That if no external force acts on a system, then the total momentum of the system remains conserved. When two moving objects collide, the total momentum of the two objects just before collision is the same as just after collision. I'm again repeating, total momentum, not individual. So when they collide, their individual momentum will definitely change, but overall momentum is going to be the same. You will understand why and how, but for that you need to refer to Newton's third law again, that no matter how heavy A or B are, they will always apply. If you remember, in the last class I took an example of apple and the earth. So apple and earth apply equal force on each other, so there is no problem with that. Okay, copy this down, then we move forward. Okay, so I think you have a brief understanding of things now, what momentum is, and I don't want to dig very deep into all this. Why? Because our way of doing things is that when we will do the previous year topical questions, there we will polish our knowledge and the application of these quantities. Right now we are wanting to understand the basics of it. So the principle of conservation of momentum, you can understand, you can take n number of examples. For example, a bomb explosion or firing of a bullet, let's say. So when you have a gun and the bullet is inside, the momentum is 0. That is why when you fire, bullet moves forward and the gun moves backward, the gun recoils. so that forward and backward momentum eventually becomes 0 again. So is there any external force? No. Gun has applied a force on the bullet and bullet has given a reaction on the gun. So there can be a number of ways of realizing this, but right now let's focus on this particular numerical. So trolley A of mass 2 kg traveling at 10 meter per second collides with a stationary trolley of mass 3 kg, which we can clearly see. The two trolleys stick together after the collision. Figure shows what happened before and after. So this is the situation before collision and this is the situation after collision. The velocity of the two combined trolleys immediately after they have collided. So we will say that initial momentum is equals to final momentum. Why? Because there is no external force. If we combine them, trolley B will apply equal and opposite force on trolley A. Okay, fine. So what is the initial momentum of trolley A? So you would write 2 times 10, okay, because mass is 2 and velocity is 10. What is the initial momentum of trolley B? The answer is going to be 3 times 0. Now, what is the final momentum of the system? Can we say that the combined mass is going to be 5 because somehow they stick together and therefore we can calculate the value of V. The value of V turns out to be 20 by 5, that is 4 meter per second. So the momentum is not going anywhere. Don't assume that this velocity 10 has become 4. Momentum is still intact, but now this velocity of 4 is acquired by more mass. Hence the momentum is balanced off. There is no change in momentum, keep that in mind. The impulse exerted by the trolley. So let's wait for this question. So I will take this question when we will discuss impulse, but the change in momentum experienced by the trolley A. So all these are interconnected, that's why I took the example of momentum here, but let's first discuss impulse and then take this question. The change in momentum experienced by trolley A. Okay, let's do this. This is going to be a fun calculation very quickly. Let's calculate the change in momentum of trolley A. So you would say P final of A minus P initial of A. So that is going to be final momentum of trolley A. So it has a mass of 2 and it has a velocity of 4 finally, because it is going as a combined system, minus 2 times 10. Okay, simple. So this is going to be 8 minus 20. So it's going to be minus 12 kg meter per second. What have I shown you? I have done the calculation of the change in momentum of A. Let's do an extra question here instead. What is the change in momentum of B? So you would say P final of B minus P initial of B. So P final of B is going to be 3 times 4 because it has acquired a velocity of 4 and its mass is 3. What was its initial momentum? You would say it was at rest. That was 0. So this value turns out to be 12 kg meter per second. Now can you realize something? Of course you can. That whatever is the change in momentum of A is just the opposite of change in momentum of B. So B has changed its momentum by plus 12, A has changed its momentum by minus 12, and if you combine them as one system, the overall change, if you add these two, is going to be 0. So that is how you explain, momentum individually has changed, there's no doubt about it, but the overall momentum does not change thanks to the fact there is no external force. So we are assuming there is no friction on the ground, there is no air resistance, only then we can expect this to happen. Copy this down, we will talk about impulse, again come to this question and discuss that. Okay, so the next thing, impulse. It is the effect of force when a large force acts for a very short duration of time. So impulse or impact is something you would associate with a sudden force. So let's take it like that. Let's say you're pushing a box, and that's not impulse. Like, that's not what you would expect in impulse. But when you kick a football, let's say, when you kick a football, that is what impulse is, because the football was in contact for a very short duration. You kicked it and it went off. So when it is like a continuous force being applied, we normally don't talk about impulse there. Impulse is something we talk about in cases of collision, right? or stuff like this. When you were jumping, let's say you jump and you ultimately collide with the ground and you suddenly stop, that is the impact. Impact word is correctly related with impulse, all right. So it is the effect of force when a large force acts for a very short duration of time. Mathematically, it is the product of force and time. To understand this very quickly, force is delta P over delta T. Since this is very small, the time is very small, force becomes very large. So can we say that delta P is force times delta T? Of course we can. Now what happens is, in case of impulse, this is very large while this is very small, and that is why this is a moderate value. Normally this is a, so just in context of this, you should always understand that why the force is large, because the time is very small and hence the change in momentum is decent. It happens, and even when the force acts for a very short duration, but since it is a very large force, it causes a decent change in momentum. Okay, so that is why when we define impulse, we rather define it in terms of product of force and time. So are you now understanding what is impulse? Impulse is nothing but force times delta T, or you can call it as the change in momentum. So have you already given the answer of this part? Of course, yes. What was the question? Calculate the impulse experienced by trolley B. The answer is already there. Okay, that's 12 kg meter per second. So impulse is something that you talk about when there is a large force acting for a very short duration of time. Okay, let's come up with one more example. Okay, so this is what I've written. It is equal to the change in momentum. Okay, a boy kicking a stationary ball of mass 0.4 kilogram with an average force of 100 Newton. The ball moved at 5 meter per second immediately. Calculate the impulse. Okay, so very quickly, impulse is going to be P final, that is 0.5 0.4 times 5. So that's going to be 2 kg meter per second. Okay, that's going to be 2 kg meter per second. What am I doing here? I am calculating the impulse of the force. I am not doing much. It is the change in momentum, but initial momentum is already 0. Why? Because the ball was stationary. So the ball was stationary and you kicked it, so it was brought in motion. So final momentum minus initial momentum is what I am doing, but initial momentum is already 0. Why? Because the ball was stationary. The time of contact between his boot and the ball. Okay, so as we know now after today's class, that force is delta P by delta T. So delta T can be delta P over the force. Okay, so what is delta P here? 2. And what is the force? 100 Newton. So what is the time of impact? 0.02 seconds. So what was the time? The actual time of impact, it's only 0.202 seconds. Easy. You understand another version of Newton's second law after today's class. You understand what is impulse, you understand what is momentum, and you do understand what do you mean by principle of conservation of momentum. That momentum is conserved when there is only balanced forces acting. There is no net unbalanced force on any system. Then you may straight away conserve the momentum. These are all easy things. You can understand them. Copy this down. Then I think we should talk about yeah, so that's all I have bought here. Maybe I can finish the class by just revising everything one more time, and then we will talk about pressure in the coming class and then various effects of force. It's an exciting series. We will talk about it. You copy this down, I move forward. All right, so yeah, this is a summary that I have made like for everything that we have talked about. So what is momentum? The product of mass and velocity. Impulse is like force times delta T, okay, or force times time. Okay, force is delta P over delta T. The principle of conservation of momentum: when objects collide, the total momentum before and after collision is same, is conserved. So all these things I hope you have understood really well. Next class we are talking about pressure and so forth. We are talking about the various other effects of forces, and then we will do the previous year questions where all these concepts will be used together. It's going to be very exciting, and many further chapters are going to be dependent on these particular concepts. So understand them really well, work really hard for this, and I will see you in the next class. But that's all for this one. Happy learning. Thank you. Bye bye. If you enjoyed this video, please don't forget to like, share and subscribe to our channel.